Well, good evening, everybody, from the First Alert Family Weather Center here in my basement in southeast Aurora, and welcome to another edition of Weather Wednesdays. I'm Mike Nelson, Chief Meteorologist at Denver 7 in Denver, and tonight we're going to talk about the crazy Colorado weather and climate that makes it so much fun to try and forecast. So, a couple of quick things. If you want to find me on email, it's mike.nelson@thedenverchannel.com. Facebook is Mike Nelson Denver 7, and Twitter is Mike Nelson 247. So let's get started. You know, the great thing about Colorado weather and what makes it so much fun is the diversity that we have in our weather. And we can go from snow to thunderstorms, severe storms, beautiful sunsets. Sometimes it's all in the exact same day. And for forecasting, that can certainly make it a challenge. My old friend Bill Custer, who did the weather in Denver back in the 1970s and 80s, used to say the weather in Colorado can be life-threatening every month of the year, and that certainly is the case. So let's talk about it a little bit. This actually happened April 15th, 4 years ago, 3 o'clock in the afternoon. We were having blizzard conditions on the northeast plains. And just east of the Denver area, out toward Bennett, we had a tornado on the ground. And that is, I've seen that more than a few times over the years of forecasting here in Colorado. So where do our storms come from? Especially in the cool season, this is where we tend to get our main storms. The Pacific front comes in off the west coast. We'll show you on TV all the heavy rain they're having in California, the snow they're picking up in the Sierras, and it'll push on into the Wasatch Mountains of Utah and dump a lot of snow there. That type of a front usually drops the majority of its snow on the mountains, and we don't get as much here in Denver across the eastern plains because these systems tend to zip on by too quickly to bring us our heaviest snows. They just are gone too fast. The mountains intercept most of the moisture, and by the time they're out of here, we just get wind and cold and maybe some flurries. Our primary storm that produces our big snows is the Colorado Hooker or the Panhandle Low, and that's when that big red L forms down over southeastern Colorado. And what that does is it allows the moisture to come up from the Gulf of Mexico and actually flow around that low pressure system right back into Denver and along the Front Range. That's when we get our really big winter and springtime snows. Case in point, the March 2003 blizzard, an upslope system. You want to go back the October 1997 storm, the Christmas Eve storm back in 1982. So the Colorado Hooker or the Panhandle Low or the Albuquerque Low, it's sometimes called, that's the primary one to bring us the biggest snows along the Front Range. There's an old adage that says, Pacific front, mountains bear the brunt, southeast low, Denver gets the snow. And then the third player, which really doesn't impact us too much, is the Alberta Clipper. That is a low-pressure system that clips, hence the name, quickly out of Alberta province. It generally goes too far north of us to bring us any significant snows, but very often we get some very windy conditions from those, and sometimes we'll have the cold winds that we call a Bora wind, B-O-R-A, with the Alberta Clipper. They tend to produce heavier snows across the Great Plains and less here in Colorado. And of course, our weather makers in Colorado, it's all dependent on the terrain and the mountains. That 14,000-foot wall out there changes everything because rising air tends to lose its moisture. As the air cools and condenses, it drops the rain and snow. Sinking air tends to be warmer and drier. So very often we have heavy snows or rains falling in the mountains, and that same westerly flow will be drier air down here on the plains. We might have Chinook conditions and be in the 60s in Denver while it's snowing like crazy up on the Continental Divide. Good way to think about it is if you were hiking with a backpack full of water bottles going uphill, you'd be dropping those water bottles off because water's heavy. It's hard to carry it uphill. So Mother Nature does the same thing, dropping that moisture out, and then as it sinks back down, it warms up and dries out. So we can very often have a situation like this, especially in the wintertime. Strong jet stream winds aloft up at, say, about 25,000 feet. But up in the high mountain valleys, we're talking Fraser, Gunnison, Alamosa, South Park, those places will have cold, dense air that pools down here in the valleys. It's too heavy and dense and too far below those strong jet stream winds, so it just sits there. And that's why we'll have temperatures way below zero for days in some of those places. While here on the eastern plains, those jet stream winds come down As they descend, they warm up about 5.5 degrees Fahrenheit for every 1,000 feet of descent. That's called adiabatic warming. And so we can have temperatures here that'll be 25 below. Up on the mountains, it might be 0. And down here in Denver, we could have temperatures in the 50s, all on the same day. Now, when you get an easterly surface wind, remember I talked about that Panhandle low or the Albuquerque low, that brings easterly winds around the low pressure system, and we get the upslope that forms here in the Denver area and along the Front Range. That rising air loses its precipitation, drops down in the form of rain or snow, and the opposite happens in the mountains. So we get downsloping winds there, and they may have sunshine. The October 15th, 1984 snowstorm, Bronco Blizzard as it's called, Mile High Stadium, Broncos against the Green Bay Packers played in a huge snowstorm. And so it's on Monday Night Football, and everybody around the entire nation is watching this giant blizzard in Denver. The Broncos ended up winning it. It was a pretty exciting game in that snowstorm. But what happened was, it was snowing here, but they had nothing going on up in Vail and Aspen. The skies were clear. But they were inundated the next day with people calling to make reservations to come out and ski, because around the country, people that didn't understand how Colorado weather works figured, hey, if they got a foot of snow in Denver, they must have gotten 2 or 3 feet up at the ski resorts. Ski areas, of course, took those reservations just fine, and eventually they did catch up with some decent snows. But that's the kind of stuff that can fool you. So, where am I? Right now I'm in my basement here in southeast Aurora, but you might wonder, where am I as far as Colorado terrain? We talk about a lot of different places. So the Cheyenne Ridge is a west to east facing higher elevation, about 1,500 feet or so higher, up in northern Weld County, up into southeastern Wyoming, southwestern Nebraska. Palmer Divide, aka Monument Hill, same thing, a west to east rising of the terrain, a little bit higher than the rest of eastern Colorado, and the same thing down here, the Raton Ridge. So Cheyenne Ridge, Palmer Divide, Raton Ridge. Front Range and the adjacent foothills in the purple here, just off to the west of the Denver area. Northern Mountains, Central Mountains, central part of the state, and southwest, the San Juans, the Lagaritas, Sangre de Cristos, the Wet Mountains down here, San Luis Valley, the Grand Mesa, Western Slope, and out on the plains. Now, again, terrain drives everything. And so what happens when we have winds that are blowing different directions, they may be going uphill on the Palmer Divide, or on the other side, downhill, coming down into Colorado Springs. So this can change all kinds of weather features that we have as far as thunderstorms, snow. And you notice this kind of bowl right here. We have higher terrain to the west of Denver, to the south, and to the north. When we get a northeasterly wind coming in here, that's why we get the heaviest snows on the west and the south side of the Denver metro area, because it's upslope. It's forcing that air to rise. Okay, we're starting to get into thunderstorm season now, and this is a way you can tell if thunderstorms are rapidly developing and will they be severe. Look at how crispy they are. If they're kind of fuzzy looking like this one, that's a storm that the rising air is kind of weakening. The updraft is weakening, so you don't get that crisp edge like you see here that looks like, say, a big stalk of cauliflower. And so fuzzy looking clouds are not necessarily going to be as strong, but when you get the crisp looking ones, that is a rapidly developing thunderstorm, and that's a sign of potentially large hail, damaging winds, very heavy rain, and possibly even tornadoes. Speaking of which, here's a nice shot of the Simla tornado in early June 2015, and 90% of our tornadoes in Colorado, we average about 50 a year, occur to the east of I-25. We get them in the mountains and foothills, but 90% are out on the flat terrain to the east of I-25. And there's a lot of open space out there. Storm chasers love to chase in Colorado because we have good visibility, we have a good road system, and we get very picturesque storms. But this is what I like to call natural crop rotation, because it was an EF2, pretty decent tornado, but it didn't hit anything. It just stayed out there and moved some of the crops around just a little bit. We can get big ones, though. We're coming up again on the anniversary of the Windsor Tornado in May of 2008. This is what that storm looked like as it was approaching Windsor. Now, this was a really unusual storm for three different reasons. One, its size. It was an EF3 to almost a 4. Two, the fact that it started so early in the day, 11:30 in the morning. Most of our tornadoes occur in the late afternoon or early evening. And three, it was so close to I-25. Again, most of our tornadoes occur east of I-25. This one started and moved from the southeast toward the northwest and was a very large tornado, especially be this close to the mountains. So that was a very unusual one. It was a tragic one. One fatality, $125 million in damage from the Windsor tornado. I want to talk a little bit about weather warnings. And if you don't have Storm Shield, you should get Storm Shield. It's our great weather app. And here's why. We have big counties in Colorado. I mean, Weld County is a huge area geographically. But our warnings tend to be pretty small. And so rather than issuing a warning for all of Larimer County and Weld County, with storm-based warnings, we only issue the warning, a little polygon, a little box that is actually included in the real threat of the tornado. And this is what Storm Shield does. It'll call you on your phone if you are in that warning. If you're not in it, if you're over here, you won't get the warning. But if you're inside of that polygon, you will get a warning on your phone. When it first came out many, many years ago, we were on vacation in Hawaii, and we were in Kauai, and my Storm Shield went off at 2 in the morning for a flash flood warning for our hotel. That's how close in it got. I was pretty impressed. The rest of the family was like, just go back to sleep. All right, so let's talk about these storms. Supercell thunderstorms are the big rotating monster storms that produce large damaging tornadoes. If you watched in recent weeks some of the terrible outbreaks of severe weather in other parts of the country, those are big rotating thunderstorms that take the energy from the jet stream and eventually transition that all the way down to the ground and cause big damaging tornadoes. We can see them on radar. This is what we call the Doppler velocity scan here. You see the red and the green. That is the radar signal actually seeing, if you will, the motion of raindrops and hailstones either moving rapidly toward the radar or away from it, and we can find the areas of rotation using Doppler radar. There's also, this is what a hook echo looks like a little fish hook, and that is the radar precipitation echo being kind of swirled around by the strong winds of that rotating thunderstorm that produces the tornado. This is actually the echo from the Windsor tornado back in 2008. Okay, so thunderstorm formation 101. Here we go. Updrafts and downdrafts. Think of a hot air balloon. The warm air is lighter, so it rises up. So that is the updraft, the hot air going up. Once it gets higher up, the moisture in it cools, condenses, and you get the cooler downdraft coming in. This is just a typical, we call an air mass thunderstorm. And where you start to get the supercell, the rotating thunderstorm, is if you have wind shear with height. In other words, maybe at the surface, a wind from the southeast, and then higher up you get a wind coming in from the northwest up at the jet stream level. You think about that rotation as that gets drawn up into the thunderstorm cloud. So that's one of the key ingredients to get a severe thunderstorm that could produce a tornado. Now, as you start to get some condensation, you get the cool air that starts to come back down a little bit. That's when we form what's called the wall cloud, which is a lowering that can actually be where a tornado will drop from. So you want to watch for that lowering. Important distinction when we're talking on TV about severe weather, whether it's a tornado warning with a tornado on the ground, or I might come on TV and mention a funnel cloud. Funnel cloud has not yet reached the ground. But in Colorado, you got to be careful because we very often have such dry air down near the surface that we might not see a condensation funnel all the way down to the surface because it's invisible. The air is still spinning down here, but you just don't see that cloud like you would in other parts of the country where there's higher humidity. And of course, tornado would be on the ground. But you want to look, if you don't see that funnel all the way down, look down here for any signs of things swirling around because that would be a tornado on the ground. It's just the condensation funnel not visible because the surface relative humidities are too low. Look at that thing. That is a rotating supercell. This looks like something out of the movie Independence Day. This great big cloud settling. You can just imagine that whole thing doing a slow rotation. And again, this is why chasers love to be in eastern Colorado because look at that great visibility and the structure of that storm system. Sometimes they'll call this a stack of plates or a mother ship. You'll hear things like that. And of course, this is the tornado. This one taken by my good friend Roger Hill, who actually has a company called Silver Lining Tours. You can look them up. I don't think they're chasing right now because of coronavirus, but Roger does storm chasing tours. He's done them for decades, where he takes a group of people out and they go to the belly of the beast right near one of these storms to see a tornado. He is in the Guinness Book of World Records. He's seen more tornadoes than any other human being, and it's somewhere up around 850 or 900 tornadoes. Cindy, do we have a question? My wife Cindy's here helping me out.
Can you get that big of a tornado in Colorado like the one you just had on there before?
Like a storm like this?
Yeah.
Yes, we get those all the time, as a matter of fact. Yeah, we see clouds like this all the time in Colorado in mainly June, July, and August, with June being the peak season for this, and primarily from east of I-25, and especially when you get out past Bennett and up toward Fort Morgan, out toward Yuma, the Burlington area. These are monster storms that we do get. I don't know where Roger shot this one, but here you can see the wall cloud right there, and then of course the funnel going on and the debris. Remember, when you see that debris, that's not just clouds necessarily. That can be rocks and bricks and broken glass flying around at high speed, and that's why we say get as low as you can with a tornado. Get to the basement, get to the lowest floor of the building you're in, and protect your head. When I talk to the school kids, talk about getting in the turtle position and getting under a table or a workbench. And, especially boys and girls, you can put on your bicycle or your ski helmet, which might sound silly, but people have survived tornadoes because they had a helmet on when things started flying around. All right, here's Tornado Alley. And although tornadoes can occur in any part of the world, they are the most prevalent right here in the central part of the United States. And there's some reasons for that. We have the Rocky Mountains to the west, the Appalachians to the east, and then we have a long plain that goes all the way up into northern Canada. So it allows cool air to easily drift southward, warm, moist air to come up from the south, and we get the big thunderstorms that form from eastern Colorado down into Texas, Oklahoma, Kansas, Nebraska, Iowa, up into Minnesota. But here's one of the key parts of this, and that is warm, dry air that comes off of the higher terrain in Arizona and New Mexico. What that does is that puts a little warmer air aloft over all of this heat and humidity down here, and it acts like a cap earlier in the day. If we didn't have this warm, dry air coming in to form a cap up there at, say, about 10 to 12,000 feet, maybe even up to 15,000 feet in the atmosphere, thunderstorms would bubble up early in the afternoon or even late morning. You'd never get this explosive development that causes the thunderstorms to really rise high up into the atmosphere violently and then interact with the jet stream. So when we say the atmosphere is capped, what we mean is this warm air is kind of sitting over here, just sort of pushing it down, keeping everything from forming into big thunderstorms. Think about this. If you had a bottle of soda and you'd taken the cap off and you had your thumb over the mouth of the bottle and you went like this, okay? That bottle is capped by your thumb. You take your thumb off, whoosh, the whole thing goes up. And that's what happens when it finally gets hot enough at the surface to break through that cap. These storms violently erupt high into the atmosphere. You get those crispy cloud edges that I talked about earlier. So we are right on the western edge of Tornado Alley here in Colorado. Now, there are different types of supercells. There's what we call an LP supercell. What that means is low precipitation supercells. They're very beautiful and dynamic. Look at the rotation. Again, that stack of dinner plates kind of look there. And the storm spotter right there taking a look at it. These oftentimes will produce not much rain, but may produce large hail, and they can produce tornadoes. But storm chasers love these not only because of their beauty, but the fact that it's fairly easy to see around, and so it's somewhat safer. Somewhat safer. Let me just say this. Chasing tornadoes is a dangerous profession, and you should only go out and do this if you've had training through the Skywarn network with the National Weather Service. You really need to know how to do this properly. You can get hit by lightning, you can get into a car accident, you can get hit by large hail, you can go off a flooded road, you can get hit by a tornado. So please do not just grab your camera or your cell phone and go out there because there's a tornado watch on the eastern plains of Colorado. Now, these are the dangerous ones. The really dangerous ones. An HP supercell is a high precipitation supercell. Look at all that rain back here. This is why they're so dangerous. A lot of lightning, a lot of large hail, very heavy rain. You can't see in here where the tornado might be. If you think about the movie Twister, when they talk about going into the bear's cage, that's what they're talking about, is going into that heavy precipitation area in an HP supercell. That's just a little fun. This came out last summer. A storm spotter friend of mine had gotten this nice tornado out near Otis. So I don't know how many of you watched the old Andy Griffith show, but there is a tornado near Otis. Be here all week, folks. Tornadoes can do some strange things. Now, this is just from the recent tornadoes in the southeastern part of the country. This really looks to me like the scene out of the movie Twister, where they drive through the house onto the other side. But look at this. Tornado takes the roof off of the kitchen, and everything is just destroyed. Trees broken, all the furniture and everything. It left a cake sitting there right on the counter, untouched. And the dishes over here, a couple of them knocked over, but they're still sitting up there in the shelf. I have seen personally from EF5 tornadoes the blades of grass that have been blown into a wall and are sticking straight out. Talk about winds of 200 miles an hour or greater. You can get some crazy stuff that develops. Okay. Now, yes, Cindy.
Amber wants to know, why do we get such random strong hailstorms?
Perfect lead into what I'm going to talk about next, as a matter of fact. This is a real common radar picture that I would see during the summertime. And you see Denver's right here, Boulder here, Fort Collins up here. Scattering of thunderstorms to the north, scattering of thunderstorms down here to the south. We get a lot of little tiny thunderstorms that build up and then kind of die away. When these storms go through their life cycle, again, you get the updraft going up, mature thunderstorm, precipitation forms, downdraft coming again. So each one of these is putting out a little gust front, if you will, just some cool air that hits the ground and fans out in all directions. And so what oftentimes happens is we get what we call colliding boundaries. And at the surface, this air coming out of these storms hits the ground, fans out in all directions. In this case, we get a boundary of cooler, moist air coming down from these storms around Fort Collins and Greeley. Another boundary of cooler, more moist air coming up. They meet right in the middle. That air can't go into the ground. It's forced to rise. And so the reason we get so many random big storms like that is you get these colliding boundaries that can form just about anywhere from any of these little storms and form a new thunderstorm that can quickly go severe and bring you large hail, heavy rain, a lot of lightning. So if you have a radar app, and I'll talk a little bit more about that in just a bit, you can oftentimes see these boundaries because even if there's not precipitation there, the radar today is so good that we can actually pick up dust and bugs blowing along with this little boundary or this gust front, and we can actually see these things getting closer and closer so that you can predict that you may get new storms forming just in the next half an hour or so. It's really cool stuff. And when they do collide, think about this air coming together like this, two different boundaries, and they hit, drawn up into the atmosphere, forming a new thunderstorm. We can get what we call land spout tornadoes. And what that is a couple of colliding boundaries hit, and this thing is like a big swirl at the surface being drawn up into the updraft. That's why land spouts tend to look like an upside down tornado. They're wider at the bottom than they are up at the top. They're a non-supercell tornado, so you don't get the big wall cloud, you don't have the giant rotating thunderstorm, but you can produce generally EF0 to EF1 force tornadoes. And I'll talk more about the Fujita scale coming up in just a bit. And these are really common in Colorado, and you'll get a lot of dust blowing around and stuff like that. Do you have another question?
Well, it's the hailstorms. So can you explain how
Yep.
the hail works?
Yep, I'm getting to that in just a bit.
Sorry.
We will get there. Yes, indeed, we will. Okay, now another threat that we have in Colorado are from straight line winds, and that would be what we call a microburst or a downburst. So what that is rain-cooled air coming down from the cloud, hits the ground, fans out in all directions. So a downburst is a non-rotating wind, fans out like this, created when a column of sinking air in a thunderstorm hits the ground, spreads out in all directions. Straight line winds that can still reach well over 100 miles an hour and cause a lot of damage. When the Weather Service goes out and says we're going to do a damage survey of the trees that are knocked down or the house that lost a roof or whatever, they're looking for the type of damage pattern that they get. Is it a swirling pattern? Does it fan out in all directions? And that's the way we can tell the difference between if it's a tornado or if it is a downburst wind. There's one more little tornado that we get, and that's called a gust-nado. That's what it kind of looks like right here. And think about like if you had a speedboat going through the water as the bow goes through, it's throwing off these little wakes like this. And this gustnado is basically just a strong wind from a thunderstorm that sort of gets swirled around. It doesn't really form a good funnel, but it'll show some rotation. And if we refer to something as a gustnado, it's typically a very weak little spin up. Oftentimes we won't even warn a tornado on that, but just call it strong winds, because it's technically, I mean, it's a rotating column of air, but not really what you'd call a tornado. Yes?
I know you're getting into this. Tiffany would like to know about why we call thunder snowstorms. Why does Colorado have thunder snowstorms?
Ah, okay. Why, Tiffany wants to know, do we get thunder snow in Colorado? In the springtime, where we are right now, we're starting to get a lot of surface heating. The sun is higher up in the sky, warms up the earth faster. That hot air balloon bubble, if you will, goes up into the atmosphere much more than it would, say, in December or January when you have a lower sun angle. So we're getting more convection in the atmosphere, more bubbling up of the storms. And so when we get a snowstorm coming through this time of year, you can very often have sort of a hybrid where you're getting snow, but you're also getting enough cumuliform clouds, the puffy ones, that you'll get thunderstorms that form as well. So thunder snow can drop a lot of snow in a big hurry. We sometimes get 2 or 3 inches per hour of snow, or you get those little Dippin' Dots from heaven, the graupel, and that's because the snowflakes are kind of getting melted and then refrozen. They form that little BB size little white dot that comes down. So if you are out and you're getting thunder snow, you're getting a thunderstorm. You want to follow all the general rules to avoid getting hit by lightning. One of the best ones is, how long does it take between the flash and the bang? It takes the sound about 5 seconds to go 1 mile. So if you're seeing lightning in the distance, start to count. 1, 2, 3, 4. Keep counting until you hear the boom. And if you get to 15, that would be 15 divided by 5. That'd be 3 miles away. If you only got to 10, it'd be 10 divided by 5. It'd be 2 miles away. So you can tell if a storm is getting closer to you. In general, if it's close enough that you can hear the thunder, you are close enough that you are in danger. So you should go indoors when you hear thunder. When thunder roars, head indoors. And then we're talking about hail. Boy, do we get some beauties here. And you always see in the parking lot at a shopping center, when we're back out at the shopping centers, all of these that look sort of like the surface of the moon from the hail. This is downtown at Civic Center Park. You see the street flooding and the hail. Our peak hail season, May through July, so we're not quite there yet, but we're getting close. When you see a storm off in the distance, if you see all this white like that, if it's a thunderstorm, you're looking at hail off in the distance, that white color, kind of the light reflecting in the background as that storm moves away. If it's not really a thunderstorm, you see a little bit of white, you might be looking at snow, but that's frozen precipitation. But if you see something like that, somebody's getting hammered pretty good by hail. And this is what it can do, of course. Look at the damage with the windshields and everything. You really need to try and get things indoors well ahead of a hailstorm. That's part of our mission, is try and warn you ahead of time when large damaging hail may occur. Wow, those are something else. Yeah.
Bonnie Lee Johnson would like you to repeat the questions.
Okay.
And also has a question.
Bonnie Lee, let's have your question.
We started hearing about weather bombs this past winter. What is this bomb technology all about?
Okay.
Or terminology, terminology.
Talk about the bomb cyclone is our question. What does that mean? What that means is nothing that's going to explode except the rapid development of the storm. If you had a barometer, you would see that barometer falling very, very quickly because that low pressure system is deepening or intensifying at such a rapid rate. These happen frequently out on the East Coast. If you hear about like a nor'easter, the big nor'eastern storms that hit out there, a lot of times off the coast, because as the interaction of cold air with the warmer Gulf Stream, you get this rapid intensification of low pressure systems. We had the bomb cyclone about 13 months ago, and it was just a typical big red L on the weather map over southeast Colorado, but it intensified so rapidly in a 24-hour period, it technically reached the bomb category, or explosive intensification or deepening of that storm. So it's one of those things like the polar vortex that came out a while back. It's always been out there in meteorology, but it kind of gets grabbed on by social media and people suddenly are talking all about it. But a good question nonetheless. All right, flash flooding and other dangers. We get into the warmer season now. It takes only 12 inches of moving water to carry away a small car. The upshot of that is, don't drive through flooded areas, because when a car starts to float, it doesn't float like a boat. What happens is the engine being heavier, it goes like this, and then it flips over. And it's one of the most dangerous things you can do is try and drive through a flooded area that you don't know how deep that water is. 6 inches of fast-moving water can knock over an adult, and 18 to 24 inches can carry away most large SUVs, vans, and even trucks. Extremely dangerous to drive through flooded areas. You have another question, Sid? Okay, we'll move on. One of the all-time greatest floods. You know, September is a funny month in Colorado because normally that's the month I always tell the brides, plan your outdoor wedding and stuff, because almost every year September is just perfect. In the 30 years that Cindy and I have lived here with our family, there's only been one very notable exception, and that was in September of 2013. We had the terrible flooding here along the Front Range. A year's worth of rain. We normally get about 16 inches of rain along the Front Range. We had that in just 5 days with this storm. And you can see the damage that it caused. This from our good friend Marcia Hobart up in Glen Haven, some of the terrible things up there just outside of Estes Park. And here are some of the rain totals from the storm event. Now you notice CocoRa's. I want to talk about that a little bit more in just a second. Here's some more rain totals. And all of these rain totals, southeast Boulder, 21 inches. These came in from what are called CocoRa's volunteers. If you're a weather nut, folks, you can do this, all right? You can become a CocoRa's volunteer. It's COCO. That's Community Collaborative Rain, Hail, and Snow Study, cocoras.org. You get a rain gauge, you get a hail pad, and that hail pad, we can tell how big the hail is by how big the dents are. And we now have over 20,000 CocoRa's volunteers worldwide, and we're just about to have our, I believe it was our 50 millionth observation comes in like this weekend from CocoRa's. It's been around since the late 1990s. It was the brainchild of Nolan Duskin, who's the former state climatologist up at Colorado State University. After the floods they had in Fort Collins back in '97, he wanted a better network of spotters. And so please consider being a CocoRa's volunteer. Question, Cindy? My wife Cindy's over here, by the way. She's helping with the question.
Dorla asks, we seem to have quickly moving storms here, save for the September 2013 rainstorm. Do we ever get a chance to see the storm edge?
Well, we do get a lot of, the question was quick moving storms with the exception of that storm back with all of the rain back here with this one. What happened with that event, by the way, is we had a front that stalled right over Colorado for several days, which normally does not occur around here. Generally, our storms tend to be kind of like the little girl with the little curl. When she's good, she's very, very good, and when she's bad, she's horrid. And so our storms are bad, but they move on, and our weather gets a lot better in a hurry. And that's partly due to the fact that we're far away from large bodies of water. We have to import that water for precipitation a long ways from the West Coast or from the Gulf of Mexico. And so generally our storms tend to be a little more moisture challenged, and that's why we only get about 15 to 18 inches of liquid moisture throughout the year along the Front Range. In the mountains, up around the Park Range near Steamboat, actually they end up with about 500 inches of snow per year up there. It's one of the wettest spots along with Wolf Creek Pass down over southeastern Colorado.
Ever see the edge?
The edge of the storm? Not quite sure I understand what she wants to know.
I think she just wants to know, can you see it coming? Can you see the storm?
Oh, yeah. We see the edge of the storm all the time because what will happen for us is instead of these giant storms that they get in the east and the Midwest, our storms tend to be a lot smaller. And so you'll see where it's raining on one side of the street, literally, and on the other side of the street, partly cloudy skies. Or it might have very heavy rain in one neighborhood and almost none just a few blocks away. That's why CocoRa's is such a cool thing, because with CocoRa's we can get this really dense network of precipitation. All right, some weather websites you might want to check out, all right? Storm Shield I talked about. If you just search Storm Shield app, you can find that one. Another one I really like is something called Weather Call. Well, they will call you on weather warnings. Locally based company as well. They do some really cool stuff, so search Weather Call. Radar Scope is an app you can put on your phone. It's a little more pricey. It's probably I can't remember what I paid the last time, $25 or something, but you can really see all those outflow boundaries and stuff because it takes the pure output from the Doppler, so you get some really cool looking stuff. Weather Tap is also a great radar resource, and OpenSnow for the snow lovers. OpenSnow.com, great forecasts, and again, a nice locally based company that can give you a lot of good information on mountain weather. And of course, can't do this without bragging about our Viero camera network, our great friends at Viero Wireless out on the Eastern Plains. We have an exclusive with these folks. They supply a lot of the cell service all over eastern Colorado, western Nebraska, Kansas, parts of Wyoming. On all those cell towers, we have high definition cameras that can pan, tilt, zoom, and we get some beautiful shots out there on the eastern plains. So kudos to our friends at Viero, because you really are eyes on the skies across eastern Colorado. Real quick, before we get into talking about climate and everything, boys and girls, if you think you're a weather nut, I want to show you one of my little gadgets here. Can you hand this to me, Cindy? This is very, very old. Okay. This is my original weather station that I built out of scrap wood. Didn't have any white paint, so I painted it yellow because we had a can of that in the garage. And inside of it, I had my thermometers. They're a little beat up now. But when I was a kid growing up in Madison, Wisconsin, I was a weather nut since I was in first grade. I was probably about 8 when I built this. Very simple to build something like this. And you can build your own little weather shelter, have your thermometers out there, mounted up on a pole in the backyard. And I kept weather records every single day for years with my little weather box there. So CocoRoz is now a way that you can kind of do this online, and it's way cooler, but I've been doing this for a long time. So let's just talk a little bit about weather versus climate. And I like to say that weather is what you get, but climate is what you expect. So climate is a long-term average. Weather is chaotic and it changes rapidly. So you would expect Miami to be warmer than Denver in February because that's the climate of Miami. So if you booked a trip to Miami to get away from the cold, unless you got bad weather, most likely you'd have an okay time in Miami. But you might get a cold front that comes through just the week that you chose to go to Florida, and it's actually 50 degrees and raining in Miami, while Denver has a Chinook wind and it's 65 and sunny. That doesn't mean that Denver's climate has suddenly changed and become different than Miami. It just means you got a bad break on your weather. So when people say to me, when we talk about climate change, hey, you guys can't even predict tomorrow's weather all the time that accurately, that's because it's easier to predict climate than it is to predict weather. You can expect that in February, Miami, most of the time, will be warmer than Denver. So it's easier to predict climate than it is to predict weather. And it's basic thermodynamics. If you add heat to something, it gets warmer. That's why day is warmer than night and why summer is warmer than winter. Now, climate change is real, folks. Talk about that a lot more next week on Weather Wednesday. But as our world gets warmer due to the increase in greenhouse gases, primarily carbon dioxide and methane, the whole planet is gradually warming up. Now, that doesn't mean that we won't get snow and cold, because that's weather and those are seasons. But it does mean that over the course of years and decades, we are seeing a continued warming of the planet due to the burning of fossil fuels. But weather will still vary greatly. December 1913, greatest snowstorm in Denver history, about 48 inches. March 2003, last really big one. Still have the streetcars. I kind of like the fact that that's still there. And I love this, the change in the way that we report them, okay? The stories have certainly changed a little bit. This was the Denver Post, December 1913, and the headline was, "Denver, Milady of the Snows jauntily doffs her graying mantle and smiles." Oh, we were so proper, yes, back then. And then 2003, it's Snow, Wind, Wallop State. Okay, but here's what a warming world does mean, folks. It does mean we can expect more droughts, wildfires, floods. They'll become more frequent and more extreme. This is along the Front Range, the fire season in 2012, the great flooding in September 2013, drought by 2014. We are juicing up the system. It's almost like the atmosphere on steroids. As it gets warmer, we'll see more of this and be more extreme. But I'm optimistic, folks, because the technology that we take for granted today, such as our cell phones, didn't exist 20, 30 years ago, and has the power of a supercomputer and then some. Our smartphones, 30 times more powerful than the first Cray 1 supercomputer, which still sits in the basement at NCAR up in Boulder. So maybe we'll get Mr. Fusion at some point along the ways, but all of the wonderful changes and inventions are going to help us solve the problems that we face. So with that in mind, next week, Earth Day, next Wednesday, we're doing a very special evening with the Denver Museum of Nature and Science. We have three great speakers, and I'll be the MC, if you will, the moderator of the panel, talking about climate change, the science, and the solutions. We were going to hold this at the IMAX Theater, but because of the coronavirus, we're now going to do it virtually. So actually, it's pretty neat because rather than only several hundred people being able to attend at the IMAX, this will be available to everybody. It will be on the Denver Channel Facebook page. We're also coordinating with the Denver Museum of Nature and Science because the changes that we're looking at, folks, as far as climate change, global warming, very important, but we can solve them. So those are my grandkids right there, and I just like to say it's not just about the polar bears. It's about our children and our grandchildren. Before we go, I think we had a couple more questions. I just want to take it. Cindy, what do you have?
Julie asks, have you seen any differences in weather or on radar since the quarantine started?
Very good point. Have we seen differences in the weather since the quarantine started? Actually, we have seen a reduction in air pollution in many locations. They're talking about they can see the Himalayas for the first time in decades in India. Los Angeles had some of the cleanest air they have seen in many, many years, one of the cleanest major cities in the world because people are driving less. So we're getting less nitrous oxide into the atmosphere. There has been a reduction in carbon dioxide emissions, but it's only been about 25% globally because obviously we're still burning fossil fuels to create electricity, and we are still adding almost at a rate of about 10 parts per billion a day of carbon dioxide in the atmosphere, and that carbon dioxide will stay in the atmosphere for centuries. So the minor change that we've seen in terms of the carbon dioxide output, we've already baked in a lot of the warming already into our atmosphere for many years to come. That's why we have to really start to come up with the solutions to stop making this worse. But in the short term, pollution has definitely dropped off quite a bit. And maybe if there's something good that can come out of this terrible pandemic, it'll be that perhaps there are some better ways that we can telecommute and we can be smarter about the things we're doing and perhaps reduce some of the pollution that we're putting into our atmosphere. Do you have one more question?
Rick asks, how is the current shutdown affecting the overall health of the planet? Is there or will there be data on this?
How is the overall health of the planet during the shutdown because of the coronavirus? As I just mentioned, we are seeing in the short term a lowering of pollution, a lowering of CO2 emissions, although they're still increasing every single day because we are still burning coal. Yeah. Ozone layer, that actually, if you remember the ozone hole that started back, we started talking about that back in the 1980s, and that was when we used CFCs, which are like in hairspray and those horns that were so obnoxious. That puts out chlorofluorocarbons, and that's a chemical that we thought was safe, but actually, when it interacts with sunlight, it eats up the ozone. Now, low-level ozone's bad. That's why we have an ozone alert, and people with breathing problems shouldn't be out and stuff. But up in the stratosphere, that's good ozone up there. It intercepts a lot of the ultraviolet lights from the sun, the ultraviolet radiation, and protects us from getting sunburn and things like that. So high-level ozone good, low-level ozone bad. Low-level ozone is lessened because we're not driving as much, not producing as much of that, not burning as much gasoline in the cars. High-level ozone has actually been healing because of the Montreal Protocol, which was passed globally back in the late 1980s. And as we took those CFCs out of the atmosphere, slowly the hole or the thinning in the ozone has gotten better. And I think that's an important spot to talk about because that is a sign of how global cooperation helped us solve a problem that the scientists saw. You know, every major sci-fi disaster film starts the same way. The scientists' warnings are ignored. Think about it. And so heed the science, understand that just like what we're talking about with coronavirus, the climate scientists are good scientists studying data. They are reporting to us that we have a problem, and it behooves us, for these reasons right there, to solve that problem. I'll close with this picture and a story that I like to tell. When Yuri Gagarin, the first human in space, got up to the top of the trajectory in his Soviet spacecraft, he looked out of his tiny little porthole and he was terrified. He wasn't afraid there was something wrong with his ship. He was terrified because his whole life he'd been taught that he lived at the bottom of a great ocean of air. And as he looked out at the cold blackness of space, it terrified him how fragile the Earth actually looked. Now, that's why for all of us, for the sake of our children, our grandchildren, for the sake of the world, we need to solve the problem we face with our changing climate. And with that, next week, mark it on your calendars, we'll have a great event coming up next Wednesday evening. I'll have more details on it as we get closer. And next Wednesday afternoon at 2 o'clock on our Weather Wednesdays, I'll talk more about climate change as well. Cindy, is there any other comment or question that we have out there?
Nope, I think you're done.
I'd like to thank my mystery helper, Cindy. And they're just waving. Here, oh, shake your hand. There we go. Where everybody can see you. There we go. There we go. There. All right. Very good. We'll have story time as well tonight. Cindy and I read stories for the kids, and after we get done with this, we'll put the story time out there, and hope everybody's staying safe and as healthy as possible. We'll all get through this. Thank you so much for your time tonight, and we'll see you again next time for Weather Wednesday.